So thank you guys for being flexible and shifting with me since I can't be on campus. You might or might not be able to tell I'm a little stuffed up and not feeling good. I don't think it's anything serious, but based on the protocol I have to follow, I'm not allowed to come to campus. um, so stay tuned for Friday's class. I'll email you either way if we're going to meet normally, like the normal green gold schedule, or on Zoom again. And I'll remind you kind of what week we are, since now I'm sure everyone's confused. So I'll tell you if the green or the gold group is meeting. But I'm waiting to hear about the next steps I need to take. And yep, I'll email you either way. So look for an email. I'll probably post a Canvas message too, just so I know everyone got it. Okay. So yeah, like I said, I think the first day of class, my son is in daycare for the first time in a year. So he got sick and now I'm sick. And so to be safe, I have to stay away from people until I get tested and get a negative test back for COVID. So I apologize for having to do this on Zoom. I know some people maybe prefer Zoom, but others I know don't. But this is kind of the best we can do in this crazy situation. So thank you for being, like I said, flexible and understanding. Feel free to ask questions as we go through this. It's weird just speaking to a black box, basically, or a bunch of black boxes on my screen. I'll have the chat box open if you have questions, or as always, you can just interrupt me. All right, let's make sure my speakers are not muted. So a couple things before we get into the lecture today. I looked at everyone's chapter outlines if you turn them in, and everyone who turned one in got a 2 out of 2. I think everyone was on the right track with what I was looking for that assignment, and hopefully it was helpful to you to at least see some of these terms. I'd gone over some before you actually did the outline, but hopefully some of the stuff we go over today that we haven't talked about yet that you saw in the chapter, hopefully it makes it a little easier to understand since you're seeing those words like a second time at least. There were a couple people where I noted just a little bit more detail here and there might be helpful for you in particular, so take note of that. But otherwise I think everyone did a good job. Everyone's on the right track with that, so that's a good baseline if you want to keep going in that direction with whatever chapter outline format you use. Some people, wrote short paragraphs. Some people answered the review questions. Some people just wrote a typical outline. And I think all those are great and useful. So you can switch it up if you want. If you want to try answering the review questions instead of making an outline or vice versa, feel free. You don't have to stick with the same format for every outline. Figure out what works for you and kind of experiment maybe and see if something might work a little bit better. Okay, so chapter outlines. Your next chapter outline for chapter 2 is due on February 1st, which is that Monday? Let's see. Yeah, that's Monday. So your next chapter outline due Monday. We're going to get into chemistry today, then we'll continue it on Friday. So you'll kind of do the chapter outline when we're sort of halfway through the chapter again. And also on Monday, your disease selection assignment is due. I know some people have already turned it in, but for the group project, the video project, you need to rank, your top 5 diseases from that list I gave you. And I'll put those groups together, hopefully Monday or Tuesday of next week. So don't forget to turn that in. It's just an Excel spreadsheet that you can download, fill out, and re-upload. Does anyone have questions about any of that? Okay, good. So yeah, outline and then disease presentation. I think that's all I wanted to cover from what I can remember. If you have lab today, we are meeting on Zoom. I sent that link out. So if you didn't get it, please email me. And I should put that on the Canvas page too, actually. Okay, so now we're gonna get back into that chapter 1. We're gonna finish up chapter 1 today and then move into some chemistry. All right, so here is the, this is where we stopped. So we talked about mapping the human body regions and did a little bit of practice with that. If you've already had lab this week, you've seen this and you've seen some of the stuff we're actually going to go over. If you haven't had lab and you're having lab today, you'll see this again in lab. So hopefully the repetition is helpful and not just boring. Well, it can be boring and helpful, I suppose. Okay, so these are the human body cavities. So we looked at the different body regions, which are just kind of different areas of the outside of the body. The cavities are the internal cavities or openings where organs are housed within the body. So there's a few different ones, and some of them are broken down into sort of smaller cavities within them. It's important to know these cavities and what organs are found in each of these cavities, which we'll talk about the organs in lab for the most part, not so much in lecture. So we're just going to go over the cavities here. There's not enough time to really go over all the organs in lecture, so we're doing that in lab. Okay, so first we have the cranial cavity. Pretty straightforward. That's where the brain is. That leads down into the spinal cavity. The spinal cavity houses the spine. Those are super easy cavities to remember. Moving down into the chest area. So the whole chest, there's multiple cavities kind of within it, but the chest cavity overall, all of these together are called the thoracic cavity. So the thoracic always refers to chest. So you hear thorax or thoracic, that means the upper part of your torso. The pleural cavities in there house the lungs. Anytime you see the word plural, which is not the like singular plural kind of spelling, it's a different spelling, the EU. That refers to lungs or respiration, anything like with breathing. So pleural cavities, there's two of them. Each one houses one lung. The pericardial cavity is aptly named. It's the cavity that surrounds the heart. So peri means around. And I like breaking down the words. If it's helpful for you, that's great. If it's not, you can ignore it. But I think knowing some of these roots, I won't go over all of them, but some of the roots you'll see over and over again, it's helpful to know sort of what that root word means. And then you can sort of determine, it helps you determine or understand or remember what that certain structure is. So peri means around. Cardial obviously refers to the heart, anything cardio. Pericardial cavity is around the heart. Okay. The mediastinum, superior mediastinum, is up here. In lab, you'll see the mediastinum listed as kind of this whole, the superior plus the pericardial cavity. On this diagram, it's just showing the superior mediastinum. So it houses the trachea and the esophagus. In lab, you'll see, like I said, the whole mediastinum, which is the superior part along with the pericardial cavity. So those two are grouped together. Sorry for the difference in those diagrams. Okay, so that's the thoracic cavity. Down into kind of the big cavity here, the abdominopelvic cavity. So we can group both of those together, call it the abdominopelvic cavity, and you can also separate them into the abdominal cavity and the pelvic cavity. So abdominal is above the pelvic cavity. We break that down actually into further quadrants and sort of subregions, which I'll show you on the next slide, because there's so many really important organs in there and it gets really complicated. They're all kind of smushed in there and on top of each other. So we break that down into even smaller pieces, but the cavity overall is the abdominopelvic cavity. Okay, so those are the human body cavities. Just something that you'll need to know. Here's a breakdown of the abdomen in particular. So the abdomen, like I said, has a lot of stuff in it. So we can break it down in a simple way into just 4 quadrants, the right and left upper and the right and left lower. Do note here, and I said this in lab, if you haven't had it, I'll say it in lab today. This is the right and left of the patient. So whoever's abdomen it is you're talking about, it's their right and left, not yours. If you're looking at a person, it's going to be opposite, right? So their right is on your left side. So the right upper quadrant here is this person's right upper quadrant. In lab, again, you're learning what are the main organs that are found in each of these quadrants, and then each of these regions, each of these 9 regions that you see on the left. For lecture, don't worry about that. Just be able to identify on a diagram what region each of these are. So if we look at this diagram on the left here, these are the regions of the abdomen. There's 9 of them. So we break it down further just to be a bit more precise. So the middle ones I think are pretty easy to remember more or less. The umbilical is the one right in the middle. It surrounds the belly button. So we know that's the umbilical region. That's the umbilical region of the abdominal region as well. So umbilical is in the middle. Gastric, you'll see gastric above and below. That refers to the stomach. So you can think of like this is the main sort of part of the stomach. Epi means on top of, so epigastric means on top of the stomach. Hypo means below, so that is below the stomach, hypogastric. So that's the 3 in the middle. On the right and left side, we just have a right and left of the same terms again. So I'll just go down the right side here. On the top, we have hypochondriac. So hypo, like I said, means below. Chondriac refers to the rib area. So it's just below the main part of the rib cage, which is kind of up in here. You can see the outline of the bottom part of the rib cage here. So right hypochondriac, right lumbar. We learned the lumbar on the back side of the body when we looked at the map of the human body. So this is kind of the same, vertically the same location on the body, but on the front. So right lumbar, left lumbar. And then down in the groin area, we have the iliac. So iliac and inguinal are used sort of interchangeably. So I think on the map of the body we used, it was the inguinal region. So this is called, on this diagram, it says right iliac and left iliac. It could be right inguinal and left inguinal as well. So just to make it a little bit more confusing. So in lab, I think the lab manual has both of those terms listed there. So you'll want to know both of them just because they're often interchanged with each other. So yeah, sorry again for all of the multiple words for one area. I don't know why they can't just decide on one. All right, so that covers the abdominal region. So memorize those locations, and if I gave you a diagram that looked like this but blank, be able to fill in the names of the different regions or the quadrants. The quadrants are pretty easy as long as you get the right and left correct. Oh, okay. Oh yeah, directional terms. We went over these in lab. For those of you in the Wednesday lab, you haven't seen these. For everyone else, you have. So I'm going to run through them again, just because repetition helps, I think, people remember and understand it a little bit better. So these terms are relative terms. So we're talking about 2 body parts when we use these and how they relate to each other as far as location on the body. So what does that mean? I'll give you some examples. We'll start with the superior and inferior. So they're always paired. One body structure will be superior to another or inferior to another. So superior means above. Inferior means below. That's what this diagram is trying to show. You can cross out cranial and caudal. I don't use those, and I don't think they're used that commonly. So that's at least a double term that you don't have to know. So superior and inferior is really all I'll ever use. So an example would be your head is superior to your torso. So your head is on top of your torso, the main part of your body. Your mouth would be inferior to your nose. So your mouth is below your nose. So above and below. So you're always going to have 2 different body parts that you're describing when you're using these directional terms. Let's do lateral and medial next. So for this, you have to imagine a midline drawn down the middle vertically of the body. So that's going to be the midline. Anything that is closer into that midline is called medial. Anything that's farther out is called lateral. So if we're looking at, we'll say the shin area here, the inside of that shin is medial, to the outside of the shin. Or the ear, if we go up to the head, the ear is going to be lateral to the nose. So the ear is further away from the midline than the nose is. The nose is always going to be medial. I don't know that there's much more of a medial structure on our body. Okay, so medial in towards the midline, lateral further out towards the sides of our body. Next, we have proximal and distal, which confuses people a good bit. Make a note that proximal and distal only refers to it's only used on the limbs. So the arms and the legs are the only time you're ever going to use proximal and distal. You can use other terms on the limbs, like lateral and medial, but proximal and distal is only used on the limbs. So proximal means whatever body part you're talking about, say the elbow, is closer to the trunk than the other body part you're talking about. So the elbow is closer into the trunk, or the attachment point here. This will be easier rather than using my arm. So the elbow is closer to the attachment point to the trunk of the body than the wrist is. So the elbow would be proximal to the wrist compared to the wrist. The wrist, thus, would be distal, further away from the trunk of the body than compared to the elbow. So the wrist is distal to the elbow. Further away versus closer in to the attachment point or the trunk of the body. You could do the same with the legs. Pause there for a second. And then finally, we have anterior, posterior, or ventral dorsal. So these two terms, anterior and ventral, mean the same thing. Posterior and dorsal mean the same thing. Anterior means towards the front of the body. Posterior means towards the back of the body. Ventral and dorsal comes from more of an animal perspective. So we're upright and we walk on two legs. So we have kind of a front and back. Most animals have a top and bottom because they're on four legs. So in that case, like a dog, its belly side would be the ventral side and its back is the dorsal side. So that's why they're not used as commonly as anterior, posterior, but I do use them some. So you want to know ventral and dorsal as well, but those are interchangeable. These two, anterior and ventral, and posterior and dorsal. Okay, so I have all these terms in a chart on the next slide here with a word definition, if that's helpful for you, instead of just that diagram, and then also examples for each one. The only one I didn't cover on that diagram is superficial and deep. So these go together. So all of these are paired. I guess I could circle each of these for you. So anterior and posterior, medial and lateral, these are all the pairs. Superior, inferior, proximal, distal, and then superficial and deep. So those are the pairs that go together. Superficial means that structure is closer to the surface of the body. Deep means it's deeper within the cavity of the body. So here, the very last example they give is the liver is deep to the skin. It sounds strange, but that just means the liver is deeper within the body than our skin is. Our skin is superficial to the liver. Any questions about those directional terms? Okay, next we have planes, which I covered in lab. So the point of these planes is basically to describe different ways we can look at the internal components of the body. So you can think of these from an imaging standpoint. So like an X-ray or an MRI, looking at these different planes will give you a different view of the organs or the structures that you're looking at. So that's why we divide the body into planes. It seems a little bit strange. And I will say, I'm not going to go over the medical imaging information that's in the chapter. A lot of you guys included that in your outline, and that's great. And it's obviously you can't predict what I'm going to go over in lecture. So I think it's another useful part of that outline assignment where you actually get a little bit more information than I have time to go over in lecture. That being said, what's on the exam is from my lectures. So anything I don't cover that's in the textbook is not going to be a question on any of the exams. But I think it's kind of a useful way to get a little bit more information since we don't have time to cover everything in class. Okay, so back to the planes. These are important with medical imaging. First, we have the transverse plane or section. So this is just very simple, as if you are cutting the body in half parallel to the floor. So this is kind of dark thinking about these planes and cutting bodies in different ways. But you can do obviously a transverse section of, say, the head, the brain, to look at it in a specific way, the abdomen. I'll show you a picture of that on the next slide. So transverse, you're just cutting it straight across so you can look down on top of whatever it is, the internal organs in this case, of the abdomen. And then you have the coronal section here, this pink one. So the coronal section or frontal, so frontal or coronal, both of those are used, is a plane down the middle of the body. If you cut someone sort of down the side, so they have a front and a back. So the body is split into an anterior and a posterior section. And then there's the sagittal and mid-sagittal. So sagittal just refers to a vertical cut down the middle of the body. So there's a right and left side. If it's right down the midline of the body, it's called mid-sagittal, or median is sometimes used. So mid-sagittal section, you can also not be right on the midline and do a cut down the side of the body vertically. And that's just a sagittal section. So maybe you don't want to cut right down the middle of the body. You want to look at organs maybe on the right side here specifically. Okay, so those are the planes of the human body. Let me show you some examples of actual sections here. So this top one is a sagittal section of the head. I don't know if it's mid-sagittal or not, but it's cut down, basically cut half of the skull off. So you see into sort of the side of the head. So you can see the brain, and then the spinal cord starting and going down into the neck there. So the beginnings of the spinal cord. So that's a very different view than if you, say, did a transverse section across the head. You wouldn't be able to see all of that detail from that perspective. So these planes just give you different perspectives. Here we have a transverse section through the abdomen. So here you can see the plane cut through the abdomen here. So you can see you're looking down into sort of the top of the abdomen. You have the liver, the stomach, the large intestine. So you can see that cross section. And then this frontal section or coronal is a section of the hip. So this is where the femur, that bone of the upper leg, fits into the hip socket from a frontal standpoint. So as if here, so it'd be this plane here. So cutting the leg in half, so there's an anterior and a posterior piece. All right. So those are the planes. We'll be looking at different sections throughout the semester for different organ systems that we're looking at. And I'll let you know kind of what the perspective is. So that's why we need to know these planes. Okay, totally switching gears. I guess not totally. But I wanted to talk briefly about the importance of precision. And a lot of you guys put this in your chapter outline from chapter 1, which is great. So as I've said, unfortunately, there are multiple names for the same thing a lot of times, and there are some terms that look really similar, but might have 1 or 2 letter differences, and they're a completely different structure of the body or a completely different physiological aspect. So it's really important to be precise. If you're detail oriented, this will benefit you. You will naturally be able to kind of keep this straight in your head. If you're not as detail oriented, you'll need to work on really focusing on the specific details, spelling, and spelling of the terms, as well as the meanings of the terms, which can often sound really similar. So that's just a plug for, it's really important to be precise in, well, in a lot of ways in life, but in healthcare professions in particular, it's really important to be precise in order for the patient. And I think patients appreciate precision. I know I would if I were getting surgery. I would want the doctor to know exactly what he's doing and not, be less than perfectly detail oriented. You want someone who's really detail oriented. And down here, I've linked a story that you can read on your own if you want. It's a really sad story, so just beware. It's about a little girl who actually died because the her medicine was not made at the correct concentration. And it was just a small, seemingly small error in calculation and terminology. So it was a really minor, just the person who made the medicine was off by just a little bit, and then it ended up leading to her death, unfortunately. So it is a really sad story, but I think it brings the point home that precision is really, really important in the healthcare fields. All right, so in the interest of time, we're a little bit behind. I'm not going to go through these review slides, but these kind of summarize the main points that we talked about. Hopefully you still remember them since we've only gone through one chapter. Talked about homeostasis, the different maps of the human body and cavities that house our organs. And at the bottom here, I note committing these terms to memory ASAP as far as the directional and mapping the human body regions terminology. The faster you commit those to memory, the better. They're going to come up. We're going into chemistry and kind of cellular stuff next, so they won't come up right away. But once we get back into kind of the body and the tissues and the skeletal and muscular systems, they're going to come up. So if you know them now and learn them now, not only will it benefit you on the first test, but it'll help you on the other tests as well. And you won't have to put so much effort into learning those other systems if you already have this vocabulary straight in your head. Okay, that wraps up chapter 1. Does anyone have any questions about that material or the class in general, just about anything? All right, I hear nothing. So let's see. We're going to move into chemistry. We can bring the PowerPoint up. There we go. And the chat box. Okay. So chemistry. This hopefully will be sort of a review for a lot of people. We go over this information, pretty much the exact same information in general biology. And you either had to take Gen Bio or like Gen Chem, I think, as a prereq for this class. So you should have a little bit of this information. I know it doesn't stick with people a lot, and a lot of people have a tough time with chemistry. So I'm going to start pretty basic. If you understand all of this already, appreciate that you understand it and that it's kind of an easy part of the class. If you don't understand it, but you've heard it before, use the second time around to really ingrain it into your head. And ask questions if you're still confused about something that you were confused about, maybe, taking your prerequisite classes. So for this chapter, we're not going into all of chemistry. We're focusing on the chemistry that relates to life, and specifically in this case, human life. So it'll be a subset of chemistry, yeah, devoted to understanding how the human body works specifically. We're not going to get into a bunch of chemistry that has nothing to do with humans, basically. All right, here we go. Where do you find that PowerPoint on Canvas? Oh, did I upload it? Let me make sure I uploaded it. Hang on. If not, I will do that right now. It should be under the modules. So if you go into the modules tab of this class, I did not put it up. Thank you. I put it up for the 8 a.m. class and did not put it here. I'm going to upload it right now. Thank you, Madison. This is going to take a second, sorry. I have to go through a lot of clicks to get to the right semester and class. Okay, here we go. 2, 2. I apologize for that. This is going to take a minute because my internet is not super fast here at home. All right. Oh, I hate that I didn't upload that for you guys ahead of time. I'm sorry. In case you wanted to print it out. But it'll be up here. We'll be going over it. I don't even think we'll finish it on Friday, so we'll still be a little bit behind. So we'll be going over it Friday and Monday. So if you want to print it out before then, that is perfectly fine. Come on. Okay, hopefully it shows up almost instantaneously for you guys. Okay, good. Thank you. Thanks, Madison. Good to know. I didn't know how quickly Canvas actually updated on your end compared to mine. Okay, so let's close that down. There we go. Those are up. The PDF or the PowerPoint version. Okay. Back to sharing the screen. Okay, so why are we talking about chemistry? I think I've made I've made my case. Maybe you don't think it's a solid case, but we talk about chemistry because basically all we are a bunch of chemicals interacting with each other, which is crazy to think about since we're so complicated. But if you break us down, you can break us down into atoms. The interactions of those atoms make us what we are. So without chemistry, life would not exist. And that sounds like a pretty big statement, and it is a big statement, but it's completely true. So if we don't understand the basics of chemistry, we don't understand how life exists at all. In addition to that, in A&P, understanding chemistry is really important because the chemistry of our body, so I've talked about blood glucose before, just glucose is a molecule, a compound within our blood. It's really important. If you have your blood glucose levels are off, you may have diabetes or develop diabetes, which is a serious disease. So understanding this chemistry is critical to understanding our health. And if you're interested in pharmacology or pharmacy at all, obviously chemistry is really important. Okay, so that's why we're talking about chemistry. Hopefully you buy into that. So I'm going to start, like I said, pretty basic. We're going to talk about elements, atoms, ions, and molecules to start, and talk about how all of these things bond together to form really important biological macromolecules. So first, an element. An element is just the simplest form of matter. It can't be made or destroyed through any like natural means. So we can destroy them, but it takes kind of superhuman power almost. And the elements are what you see in the periodic table. So if you look at a periodic table, those are the elements. There are 24 of those in the periodic table. And I meant to look this up. I don't actually know how many elements there are in the periodic table, but there's more than 24. But all you have to worry about, and you don't even have to worry about all the 24, but from a human biology perspective, only 24 elements play a biological role. Six of them, so six of those 24 are the ones you want to be really familiar with. They make up the vast majority, 99% of our body mass. These are oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. So if you're not familiar with the chemical symbols for these elements, make note of them and be able to recognize the element based on just the chemical symbol. So O is oxygen. Most of them make sense. Yeah, all of those do, calcium, phosphorus. Yeah, all of these are pretty straightforward. There's some like K is potassium that aren't quite as straightforward. But you definitely want to know these elements, be able to name them and write their chemical symbol, which is just these letters. The vast majority of what we're going to be talking about is CH and O. So these are going to show up over and over again. We're going to learn a lot about how they bond with other molecules and some of their properties. So carbon, hydrogen, and oxygen, really, really critical. There are some other elements beyond these six that are considered trace elements. So they're still within this 24 element biological role category. They're just not one of these six, obviously. So these trace elements are required in really tiny amounts. So we don't have much of them in our bodies, but they are really important in physiological function. So tiny amount, but if we don't have them, we can't survive. So they're still really important, even though they're only found in small traces. And I'll show you what those are in a couple slides. Okay. Minerals are sort of a subset of elements, some of which I mentioned already, calcium and phosphorus, that are biologically important, but we have to obtain them from plants, either directly or indirectly. So we either eat the plants or we eat the animals that eat the plants. They are inorganic elements that are taken out of the soil by plants. So that's how they make their way into our system. Oxygen, obviously, we inhale. We don't need a plant. Well, we do need plants. They produce the oxygen, but we don't have to eat a plant to get oxygen, right? So for these minerals specifically, we need to consume plants directly or indirectly. They make up about 4% of our body mass. Beyond calcium and phosphorus, we have chlorine, that's Cl, magnesium, Mg. Here's potassium, which is K, sodium, Na, and then sulfur is S. These are really important primarily in body structure, by and large. So our bones and our teeth use a lot of minerals. We know that calcium in particular is really important for our bones to form properly and to be strong. They also have enzymatic function, and I'll talk about enzymes towards the end of this chapter, but enzymes basically help chemical reactions proceed a little bit faster in our body. So I'll get into them in a little bit, but minerals, really the main function of them is for physical structure of our body. Okay, so here I have just a simple diagram showing the different elements, which we've talked about, and then the percentage, I can't see because the chat box is in the way, the percentage that is, that's made up in our body. So oxygen is kind of right at the top there. And then there's the carbon and hydrogen. So again, CH and O are going to pop up over and over again. They're really critical. Down here, you see the trace elements. So I didn't mention what the trace elements are. There's a lot that you probably don't really recognize. You don't have to memorize these trace elements. Just know that they're in small amounts, but really critical to our functionality. Some of these I'm not even really familiar with, like vanadium. I don't know what that is, but copper you've probably heard of. Iron, obviously you've heard of. That's really important in our blood to help carry oxygen around our body. All right, so that's just a nice kind of diagram summary of the important elements of the human body. Okay, moving into some basic sort of atomic chemistry, which just means looking at atoms. And I want to take some time here. How much time do I have? All right, I have 8 minutes. I'm going to take really as much time. We might have to go into Friday a little bit with this, but I want to make sure everyone understands the basic structure of an atom and why the structure of an atom matters so much when it comes to two atoms bonding together. So that's what we're moving towards. We're moving towards looking at how atoms bond together to make these bigger molecules that we actually use in our body. So if we break down, if we look at an element, an atom, so one piece of an element, we can look at it using what we call the planetary model, and you can kind of see why it's called the planetary model. There's this kind of central piece with things orbiting around it. So we have the nucleus here. I'll move over to this diagram. The nucleus with these rings around it. So that's why we call it the planetary model. You may have seen this when you did your chapter outline, and it was developed by Niels Bohr. You don't have to know that, but if you saw the Bohr planetary model, that's what this is. This is just a way to represent an atom since we can't see them. So this is a simple representation of an atom. In the middle, like I said, we have the nucleus. So in the nucleus, we have neutrons and protons. Protons are positively charged particles. Neutrons are neutral. They don't have a charge. We, for the most part, don't care about the nucleus as far as what we're going to be talking about. So we can ignore the nucleus. We are concerned with this cloud of electrons that's swirling around the nucleus. And over here, it's a much more simplified version of that. So electrons are the negatively charged particles of an atom. So we have positive protons, neutral neutrons, and negative electrons. Electrons are orbiting the nucleus in these energy levels or energy shells or electron shells. All of those are sort of used interchangeably. There's usually multiple energy levels, so more than one electron except for hydrogen. So hydrogen is going to be our exception for most of these, and I'll kind of refer back to when I say something, I'll say except for hydrogen, which blah, blah, blah. So you'll hear that a lot. So keep in mind, hydrogen is slightly different from the vast majority of the other atoms we'll talk about. So when we're talking about the atom, we don't really care about the nucleus for our purposes. We also don't really care about any other electron or energy shell other than the outermost one. So the outermost energy shell I've noted here is called the valence shell. So the first energy level has to be filled before a second energy level will develop. And each element has a very specific number of electrons. So we can predict how many energy levels there are and how these electrons are organized across those energy levels. So here, the first energy level, and you're going to want to write this down because I don't think I have it in bullet points. The first energy level of any atom can only hold 2 electrons. So you see these 2 blue dots here. Only 2 electrons fit in that first energy level. All of the energy levels beyond that, for our purposes, we won't really go beyond 3 energy levels, I don't think. So the second and third energy levels, so here and here, they can each hold 8 electrons. So sodium here, you see, has 2 electrons in the first energy level. So the next 8 electrons it has are going to go into that second energy level, so it gets filled up. When that second energy level is filled with 8 electrons, a third energy level develops if there's more electrons that need to be placed somewhere. And there is 1 electron in that third energy level for sodium. So first energy level only holds 2 electrons. Second and third will each hold 8. And again, those valence electrons are what we care about. So the valence electrons are the electrons in the outermost shell. So I've defined that here. We're going to run out of time, aren't we? All right, just a couple more minutes here. Hydrogen, like I said, it's a really tiny atom. It only has 1 electron. It's a very simple atom. It's nice in that sense. It only has 1 electron. It only has 1 electron shell. So only 2 electrons will fit here. So it only needs one more. It wants to fill, so I should step back here and say every atom wants to fill its outermost electron shell, so its valence shell. In hydrogen's case, that means it only needs one more electron, right, to fill its outermost shell, because there's only one shell, which only holds 2 electrons. For everything else, C, N, and O, we're going to see over and over again. They all have 2 shells. So oxygen filling its outermost energy shell, it has 6 valence electrons. So it actually needs just 2 more to get to 8, because it can hold 8. Atoms want to get to 8 electrons, except for hydrogen again, because it only has 1 energy shell, so it only needs 2. So that brings us to the octet rule. The octet rule means that atoms want to fill their valence shells. And I know that sort of anthropomorphizes atoms. They're not human. I get that. They don't have wants and needs. But that's how I think of it. They want to get 8 electrons. They want to fill their valence shell. And I'll show you how to predict and predict how many valence electrons every element has. I'll show you that on Friday on the periodic table. It's really easy to see. So oxygen only needs 2 more, so it's fairly reactive. It can react with a lot of different things that can share electrons with it, so it fills up its outermost shell. Nitrogen has 5, so it needs 3 more. Carbon only has 4 in its outermost shell, so it needs 4 more. That sets it up for some interesting bonding, actually. So carbon will kind of be the backbone of most of our big molecules we're talking about, because it has these 4 valence electrons, which I'll talk about more in a little bit. But take-home message for today for this chemistry lesson is that atoms are going to try to fill their valence shells by either sharing electrons, transferring electrons, mostly just sharing and transferring electrons between 2 atoms. That's what's going to bond them together in order to fill the valence shell. All right. And that wraps up our time. Sorry, I went right up to the end there. Hopefully, if you guys have any questions, feel free to email me, or you can stay on and ask me now if you want to. And I'll email you either way about what we're doing on Friday, all Zoom or back to kind of normal. All right, and we're done for today.